For this lesson, we're going to continue with our work on factoring, and in particular factoring trinomials that are complex. And that means that the coefficient in front of the x squared term is going to not be 1. We've done factoring of simple trinomials in a previous lesson, and in that case we had the a value was equal to 1. So now we're going to look at more complex examples. As I have before, I'm going to start by introducing this through algebra tiles. So the way that we factor using algebra tiles, it's a visual model, and we start by building an area based on these components. So I normally like to start in my top left-hand corner with 3x squared in this case. I could have done this horizontally or vertically, but I'm doing it horizontally because of screen space. And then I've got the same options, horizontal or vertical, for my 2. Now, something that I recommend when people are working with algebra tiles is, in general, try to make your shape more square and less long and rectangular. So the more squarish you can make it, the better off you are. You're not going to get a perfect square under most circumstances, but the more you can make it like a square, the better off I think you'll be. Now that doesn't mean it's always going to work, but it does save you falling into certain pitfalls. So I'm going to try to do that here and see if it works out. So in this case I need 7 x's now. I can only fit a single x here, but if you can visualize it, I can fit 6 more x's in these locations. So I can go ahead and do that. And there we go. I've got everything that I needed for that one. I'm going to just move this down a little bit. And reading across, I have an x and an x and an x and a 1. I have an x and a 1 and a 1. So in factored form, this is 3 x's plus 1, and then vertically I have x plus 2. So I've gone from standard form of a complex trinomial to factored form. 2x squared minus 3. So I will arrange this again more square and less long in the rectangle. And now minus x. So what can I do here? Now I'm already looking ahead. I can actually see that this isn't going to work out. I can put a negative x here. That doesn't actually help me. Or a positive x here. And the problem I'm running into is all of the spaces I have here. And again, if you can visualize it, there's actually room here for 1, 2, 3, 4, 5, 6 more tiles. So this is not the right configuration. So I have to back out what I've done, and I'm going to have to reconfigure these. And now I've got room for 1, 2, 3, and 1, 2 here. But I want my overall x's to be negative x, so I need more negatives than positives. So negative 1, negative 2, negative 3, positive 1, positive 2, and then negative 3 and positive 2 gives me a total of negative x. I have an x, I have an x, negative 1, negative 1, negative 1. I have an x, and I have a positive 1. Never a bad idea. Just check, make sure. The x times x is pretty clear, but what about these values down here? Negative 1 times positive 1 equals negative 1. So yes, these values do work as well. You do need to double check these things. Sometimes you can find layouts that work for the x squareds, they work for the x's, but they won't actually work for your constants. So you do have to be diligent about this. I have 2 x's minus 3 across the top. I have x plus 1 along the side. Okay, so now let's start to look at this from an algebraic perspective. And in order to do that, just a very quick review of going the opposite direction. So if I expand some brackets, I'm going to end up taking it from factored form to standard form. And then when we talk about factoring, we want to go from standard form back to factored form. So it's important for us to look at the simpler of those two processes, which is to expand. I can expand using FOIL, or I could expand using an area model. So I could take x plus 4 and 2x plus 3. Whichever one of those you're more comfortable with. I'm going to use FOIL in this case. So I start off by multiplying the first values. That's x times 2x, gives me 2x squared. Then the outer values, that's going to be x times 3 for a 3x. Then the inner values is going to be 4 times 2x, that's plus 8x. And the last values, which are 4 times 3, which is 12. And now that I have these, I notice that these two middle values actually have the same variable x. So the 2x squared doesn't change. This becomes 11x in the middle, and then the plus 12 on the end doesn't change. So these two combine to give me positive 11x. In order to reverse this, if I want to now go from here back to factored form, I'm going to need to take note of a couple of things, and you can see I've mentioned them down here. I'm trying to highlight them. We've got the numbers 3 and 8, which were these two middle terms. How do these numbers 3 and 8 relate to the different numbers in the final form, in standard form, 2, 11, and 12? And there's two relationships here that I want you to see. One of them is that 3 plus 8 is equal to 12. So these two numbers added together to give you 11. So imagine now if we're going to reverse the direction, we need to start, we're going to be starting with the 11 and going backwards and somehow getting this 3 and 8. And then the other thing I want you to see is, the other relationship that's here is that 3 times 8. So here I've got sum, and here I have a product. 3 times 8 is actually the same as 2 times 12, and both of those, of course, are equal to 24. So this idea of sum and product is going to come into play. Okay, so for now, we are going to ignore the fact that this middle term, this 11x, turned into 3x plus 8x. For now, it's magic. We're just going to assume that it happened. So we've got these relationships, the sum and product relationships, and our first step in looking at this is, well, what if this was actually done for us? What could we do? Well, now we can factor by grouping. I can take that first pair. What is common between 2 and 3? Actually, the only thing that's common between 2 and 3 is 1. What's common between x squared and x? That's an x. Now, what is 2x squared divided by 1x? That's going to give me 2x. And what is positive 3x divided by 1x? That's going to give me positive 3. Then, the next thing you do is you always take the sign between your first group and your second group. You bring that sign down. And then I'm going to factor this second group. The second group, for the constants, 8 and 12, what's common? It's going to be 4, and because this is a positive sign, it's going to be positive 4. Between the variables, I have x here, and I actually don't have a variable here, which means it's just the number 1. So there is nothing in common between those, so I leave them as is. What is 8x, positive 8x divided by positive 4? That's equal to 2x. Positive 12 divided by positive 4, that's equal to positive 3. And if you've done things correctly, and make sure you're honest about this, but now you can perform a check, which is take a look, and you should see that this factor is the same as this factor. And if these two factors are the same, they are common factors. The fact that there's addition inside this bracket is irrelevant. We are thinking of the factor as whatever that thing is in the brackets. So I'm going to take whatever that thing is in the brackets here, so that's 2x plus 3, and then I'm going to multiply that by, well, when I take this whole first, consider this whole first term, and when I divide out 2x plus 3, what's left over? Another way to ask yourself this would be, what do I multiply this whole bracket by in order to get back to 1x times the bracket? Well, obviously the only thing missing here is the 1x, which we don't normally write the 1x, so I'll just write x. Same thing is true here. What do I multiply 2x by 3 by to end up with this whole expression? Well, this is 4 times 2x plus 3. So the thing that's missing here is the positive 4. And that is our factored form. And if you were to look back, you would see this is what we originally started with when we expanded. So if we have this magical first step where I've split the middle term, it seems like things can work. Factoring by grouping is a skill that we looked at in the lesson on common factors. Okay, that being the case, how do we find that middle term? To do that, we're actually going to do a brand new problem. And the middle term has to do with a sum. If we go all the way back to what I had pointed out before, we have these two relationships. So the middle term, which in this case was 11, we needed something that added to 11. 3 and 8 were the numbers we wanted, 3x and 8x, and they added to the middle term 11x. We also had these numbers 3 and 8. They multiplied to the product of the first term and the last term. So we're going to make use of that idea. So in this case, our middle term is 13. So we want to add to 13. We want to multiply to the product of the first coefficient and the last constant. So 6 times negative 5 is negative 30. When you look at values, what you want to do is you want to look at the product first rather than the sum. So start with the product and then work with the sum. The reason for that is that there are a finite number of combinations that will give me negative 30. But there are an infinite number of ways to add up to 13. So there's no point in starting with something that has an infinite number of solutions. We start with a finite number of solutions. And in this case, I'm actually going to always start by ignoring the negative sign. So how can I multiply things together to end up getting negative 30 but positive 13? Well, I'm going to start with my multiplications. I can do 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, that works, and 6 times 5. As soon as I get to this point, I've actually just got the same expression, but I've reversed direction. So there's value in trying to do these things in order. I don't need to consider this one at all. Now, let's take a look at the idea of sum. I need to consider this negative sign. The only way I could do that would be either negative 1 times 30, or I could do 1 times negative 30. Now, let's consider what would happen if we added those together. Well, let's start with the one that I've got here. 1 plus negative 30 would be negative 29. Well, that's not even positive. This one is positive. So if we want a positive, then what we need to do is the smaller number. If this is positive, then that means the bigger number is positive, the smaller number is negative. And so that will give me positive 29. So I'm going to make all of these smaller numbers negative. This one adds to 13, this one adds to 7, this one adds to 1. We could have, of course, stopped here because we now have our answer. This is wrong, but I continued. This is obviously wrong, this is obviously wrong. If you've done your work correctly, there is only going to be one answer. So my values are negative 2 and positive 15. This technique has an acronym called SPI, and that stands for the sum. We're interested in the sum, we're interested in the product, and we're interested in the integers that will get us that particular sum and product. Okay, so now that we've done this, we know that the number 13 can be broken up into -2 and +15. So what we do now is we rewrite this as 6m squared, but instead of 13m, I write it as -2m plus 15m. So I have broken this middle term. That used to be 13m. And I have -5 on the end. Now, it doesn't actually matter if you write it this way or if you reverse that. If you wrote that as plus 15m minus 2m. Both of those are still correct. And as a matter of fact, I'm going to just leave it this second way because having this negative sign here, it gives me the opportunity to illustrate another important idea. Between 6 and 15, the common factor is 3. Between m squared and m, the common factor is m. 6m squared, well, let's start with the numbers. 6 divided by 3 is 2. M squared divided by m is m. Positive 15 divided by 3 is positive 5. M divided by m is equal to 1. Now, I keep this negative sign no matter what. Between 2 and 5, the common factor, they're both prime numbers, the common factor is 1. Between m and 1, there's no m here, so that's the number 1. The common factor is a 1 again, so I just leave that as a 1. -2 divided by -1, and this is where things are interesting in the sense you have to pay attention. -2 divided by -1 is positive 2. And we didn't divide by an m here, so that just stays as m. -5 divided by -1 is positive 5. And we check, it turns out both of these are the same. So now I take that common factor, and when I factor 2m plus 5 out of this whole term, the only thing that's left behind is 3m. And when I take 2m plus 5 and factor it out of this term, the only thing that's left behind is -1. And so there we have our factored form. One last example. And in this case, I've suggested you do this using an area model. I'm still going to use SPI, and how you choose to write it is up to you. So in this case, maybe you, because it's SPI, you might write it as sum and product first. It doesn't matter how you actually lay this out. This is all rough work going on your side of the paper. And the area model means I take these values, 10x squared and -6. I can fill in the top left and the bottom right immediately. But I don't know what goes here. These are the two integer values that we're looking for. So I want a sum of -11, and I want a product of 10 times -6, which is -60. So remember, the product is the first coefficient multiplied by the constant at the end. Okay, I want a sum. Okay, let's look at the product of 60 first of all. That's 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12. You can see how it helps to know your times tables here. 6 times 10, 7, 8, 9. So the next one is 10 times 6. And 10 times 6 is just the reverse of 6 times 10, so I don't need that one. Now, where do I put my product is -60, so where do I put my negative sign? In this case, my sum is -11. That means the bigger number is the one that has to be negative. And I take a look at my sums. -59, that's not right. -28 is not right. -17 is not right. -11, that's the right one. And just to finish it off, that's a -7, and that's a -4, and those are both obviously wrong. So those are my values, which means one of these has to be a 4x, and one of these has to be a -15x. Once you have that, I recommend you either go to this space or to this space, dealing with the simpler terms, dealing with whatever includes this constant in the corner. So I'm going to start over here on the left side, what is common between 4 and negative 6? And whenever you pull over here, use the sign. So this is a positive 4. So between 4 and 6, the common factor is 2. So I'm going to put a positive 2 here. And now, between positive 2, well, what do I have to multiply by positive 2 to get negative 6? That's negative 3. This table starts to fill itself in for you very quickly. So 2 times negative 3 is this. Okay, well, I've got a positive 2 here. What do I multiply by positive 2 to get 4x? That's 2x. 2x times positive 2. And now that I have a 2x here, well, what do I multiply by 2x to get 10x squared? That gives me a 5x. And then a quick check mentally, 5x times negative 3, negative 15x. We already know this is correct, so that looks good. And my answer then ends up being 2x minus 3 and 5x plus 2. So you can see some of the work was the same. The sum and product part was the same. But how we came up with these values, essentially, it's a different way, or it's kind of an alternate method to factoring by grouping. So if you're having a hard time with factoring by grouping, you might want to try this area model instead, because now you're just really doing common factors. You're not factoring by grouping because the groups are already done for you. You don't have to worry about the groups. It's being done for you automatically. Okay, so that is how we factor complex trinomials. Here is the assigned work, and that's it for this lesson.